Welcome to the first lecture of linear algebra. I'm Engineer Carl Gallardo. I'll be a teacher in this course. For the first lecture, we have the matrices, definition, types, and properties. By the end of this discussion, you should be able to define what a matrix is, define the dimension of a matrix, and learn the different properties of matrices. First, let's talk about what linear algebra is, since this is our course. Linear algebra is a branch of mathematics that is concerned with mathematical structures closed under the operations of addition and scalar multiplication, and that includes the theory of system of linear equations, matrices, determinants, vector spaces, and linear transformations. Here in linear algebra, we are going to deal with matrices. What is a matrix? A matrix is a rectangular array of elements arranged in rows and columns. Okay, it's a rectangular array of elements arranged in rows and columns, enclosed in parentheses or brackets. Okay, here you have an example, 3 examples. The first matrix is enclosed in parentheses, and the second and third are enclosed in brackets. Here in this course, we are going to use brackets. Let's have the notation, entries, and size of a matrix. Considering the matrix below, we call this matrix A. Okay, usually we use a capital letter to denote or to name a matrix. Okay, matrix A is a matrix composed of A sub ij, where I is the row and j is the column. Okay, here we have m rows and we have n columns. Each element of a matrix is called an entry with unique ith row and jth column position. For example, A sub 1, 1 means that I is equal to 1 and j is equal to 1. Hence, it is the entry in the first row, first column. For larger matrices, a comma usually separates I and j such that A sub 12, 25. So it means that the entry is in the 12th row and the 25th column. Second remarks. The size, dimension, or order of a matrix is m by n, where m and n are greater than or equal to 1, and both are positive integers. An n by n matrix has a total of m times n entries. Example 1. Given the following matrices, determine the size and solve for the required operations involving some elements. Okay, we have here 8 matrices. I'm going to answer the ones with the black. Okay, what is the size of matrix M? So the size of matrix M is 1 row, 4 columns. So the size or the dimension is 1 by 4. For B, you have 4 rows, 1 column. So you have 4 by 1. For matrix T, you have 3 by 3, 3 rows by 3 columns. And then for Q, we have 3 rows by 2 columns. For W, U, Y, and K, the sizes of them are left as exercise. Let us now compute the following. Take note that we can get any of the element of the given matrices and relate them to one another. Compute the following. M sub 1, 3 plus T sub 3, 3 equals. Okay, for M sub 1, 3, of course, we're going to look at the matrix M. So we are finding the first row, third column entry. So this is it. So we have negative 4. And then next, for matrix T, that would be third row, third column. Okay, we have negative 4 plus 0, we have negative 4. Next, the quantity K sub 1, 1 minus Y sub 2, 2, all raised to Q raised to 3, 1. Okay, let us set it up first. K sub 1, 1, first row, first column is X. Okay, and then for Y2, 2, second row, second column. This is it. So we have this one. X minus negative 5. Be careful with the sign. And then they have an exponent. Okay, Q raised to 3, 1, third row, first column. You have this one. Okay, inside we get X plus 5, all raised to 0. Take note that any number except 0 when raised to 0 is equal to positive 1. So this one is equal to 1. Except negative 5. Why is that? Because negative 5 plus 5 will be equal to 0. 0 raised to 0 is not defined. So it is indeterminate. Last, we have U sub 1, 3. First row, third column of U. Okay, you have 11. And then plus P sub 4, 1, fourth row, first column. Okay, you have this one. Minus, plus, negative 5. And then minus W sub 2, 1. W sub 2, 1. So that is second row, first column. Positive 5. Let us now discuss the types of matrices. First, we have the rectangular matrix. A rectangular matrix is an m by n matrix with m is not equal to n, meaning to say the number of rows is not equal to the number of columns. These are our example. Next, square matrix. A square matrix is a matrix with the number of rows is equal to the number of columns. Here we have a 2 by 2 matrix. Here we have a 4 by 4 matrix. And here we have 3 by 3. Another type of matrices is the row vector and the column vector. A row vector is a 1 by n matrix, while a column vector is an m by m matrix. Next, a special type of the square matrix is what we call the identity matrix or unit matrix. It is a square matrix whose elements of the principal or main diagonal are 1 and the rest is 0. Okay, we have here the main diagonal that we call. Okay, we have this and then this one. Upper triangular matrix and lower triangular matrix. For the upper triangular matrix, the elements below the principal diagonal are all 0. This is the principal diagonal, so always remember that. So the direction in drawing the principal diagonal is always going to the bottom. Okay, this is not, baka mamaya ganito yung gawin nyo. Eto, hindi ganyan yung main diagonal, so laging pababa. Okay, the first one is the upper triangular matrix. Always remember kung saan kami mga values, ayan, nandun ka. So, ito ay upper. And then, ito naman, lower triangular matrix. The rest ng mga elements, puro 0 na. 6th and 7th, we have the diagonal matrix. It is a square matrix whose elements above and below the principal diagonal are all 0. Regardless of the value on the main diagonal or the principal diagonal. 7th, we have the scalar matrix. This one is a diagonal matrix whose elements of the principal diagonal are all equal. So this one is a scalar matrix. Whenever you encounter a matrix with equal elements in the diagonal, so that is scalar. And then aside from that, all elements above and below are 0. 8th, we have the null matrix or the zero matrix. This one is the easiest of all. A null matrix is a matrix whose elements are all 0. Next, let's have the properties of matrices. We have the equality of matrices. Two matrices A and B are equal if and only if they have the same dimension and elements. Example, what must be the value of the unknowns for the two matrices to be equal? Okay, in the equality of matrices, we just have to equate the corresponding entries. Meaning to say, the first row of the first matrix is equal to the first row of the other one, so that we can solve the unknowns. Okay, we have 1 plus 4 equals A. Therefore, A is equal to 5. Okay, how about for B? For B, we have B plus 5. Let's start with this. B plus 5 equals 3. So, therefore, B is equal to negative 2. And then last but not the least, the C. We have here C minus 2 equals 2. Okay, we have C equals 2 plus 2. Okay, C is equal to 4. Okay, I will leave it to you as an exercise how to find Z, X, and Y. Another properties of the matrices are, we have the reflexive property. Matrix A is equal to itself. That is reflexive. Third, symmetric property. Suppose A and B are matrices. If A is equal to B, then B is equal to A. Fourth, the transitive property. Suppose that we have A, B, and C as matrices. If A is equal to B and B is equal to C, and then A is equal to C. Have now reached the end of this discussion. You are highly encouraged to answer the following exercise.